Hello everyone, this is Dr. Mo Shiva, Professor of Electrical Engineering Department at California State University, Fullerton. The purpose of this video is to review superposition. I've already done one video on superposition. If you have not seen that, please go ahead and review that first and then come back to this video. I'm assuming you're familiar with basics of superposition. To do a very quick review, superposition says the response, a voltage or a current, at any point in a linear circuit caused by two or more independent sources is equal to algebraic sum of the responses caused by each independent source acting alone. Emphasis on independent source. If you have nothing to do with dependent sources, they will remain in the circuit. A superposition could simplify a problem. So instead of mesh analysis or nodal analysis, we can get away with voltage division, current division, simpler methods basically. However, generally, superposition does not simplify the solution if there are dependent sources in the circuit. So let's do an example. In the circuit, we have two independent sources, a voltage source on the top and a current source in the middle. We look at one independent source at a time. So first, let us keep the voltage source. That gives us this circuit. The independent current source is replaced by a source with zero current, so it's acting like open circuit now. Looking at that circuit, the current I1 is at the bottom and it's going clockwise. Let us write Kirchhoff's voltage law for the outer loop. First term is positive 2I1. Don't pay attention to negative of Vx1. We're looking at voltage drop across the resistors using passive sign conventions. And I have described that in my examples and videos for mesh analysis. If you have not seen that, go and review those. So first term is 2I1. Continuing, we see the negative side of the voltage source. So change the sign of the voltage, negative, negative 4, followed by 3I1, and finally 5Vx, Vx1 in this case, equal to 0, and Vx1 is voltage is resistance times current entering positive reference of the voltage. So that makes this negative 2I1, current being negative I1. First equation gives us 5Vx1 plus 5I1 equal to negative 4. Substitute for Vx1, we have 5 times negative 2I1 plus 5I1 equal to negative 4. And from here, I1 is 4 over 5 equal to 0.8. And next, we keep the current source and short circuit the voltage source, killing a voltage source. 0 voltage is short circuit. So current I2 is at the bottom. Using that, current going to the left at the bottom is I2 minus 2. Let us apply Kirchhoff's voltage law to the outer loop. So here we're keeping the current source, starting at the lower left corner and going clockwise. Again, voltage across the 2 ohm resistor, don't pay attention to polarity of Vx2, is positive Ri, so positive 2 times I2 minus 2, continuing plus 3I2 plus 5Vx2 equal to 0. Call this equation 1. And Vx2 is 2 times current entering positive side of Vx2. That current being negative of I2 minus 2. So Vx2 is negative 2 I2 minus 2. Substitute that in the previous equation. We get so we substitute for Vx here. We have 2 I2 minus 2 plus 3 I2 plus 5 times negative 2 times I2 minus 2 equal to 0. Simplify. We have negative 5I2 plus 16 equal to 0. And that gives us I2. .2 amps. According to superposition, current I is I1 plus I2 equal to 4 amps. Let us call this equation 2. As I mentioned before, if we have dependent sources, superposition usually doesn't save us any time or effort. It really simplifies the problems if we only have independent sources. To observe that, let us solve the original problem without using superposition. Down here, current is I, so subtract 2 from it, Kirchhoff's current law. Current moving left is I minus 2. Write the equation for Kirchhoff's voltage law applied to the outer loop. We have 2 starting at the lower left corner, I minus 2. We see the negative of the voltage source, so minus negative 4 plus 3I2 plus 5Vx equal to 0. Call this equation 3. And we need Vx. So Vx is negative 2 I minus 2. 2 times current entering positive reference of Vx. Let's call this equation 4. Comparing equation 4 to equation 2, we see these are pretty much the same. Instead of I2, we have I here. So that's same as equation 2. And compare equation 3 to equation 1. The only difference is one extra term here. This exists in 3 and doesn't exist in 1. So otherwise, we really don't need to solve two problems. One for first circuit up here and one for the second circuit. These two equations basically do the job, and the problem is straightforward. Superposition really doesn't help us much. So to solve these equations, use equation 3. We are looking at 2 times I minus 2 plus 4 plus 3I. That should be I, by the way. Plus 5Vx plus 5 times negative 2 I minus 2 equal to 0. And that simply gives us minus 5I, negative 5I plus 20 equal to 0, and I equal to 4. So as you have observed, superposition, if you have dependent sources, really does not simplify the problem that much. So please go ahead and review the first video on superposition, and I have future videos for other methods used in analysis of linear circuits. Thank you.